let's go over the concept of limiting and excess reagent. So, a limiting reagent is a reagent that is used up first in a chemical reaction, and an excess reagent is a reagent that is going to remain when a chemical reaction happens. And so, when you're comparing two reactants, the one that is going to finish first is the limiting reagent. The one which is going to remain is the excess reagent. And so because one is finishing first, that is the one that is going to determine how much product is going to be formed. So when you want to determine the limiting reagent, there are a number of ways that we can use. I'm going to show two ways in which we can find or determine the limiting reagent as for the first question here. So nitrogen gas can be prepared by passing gaseous ammonia over solid copper oxide at high temperatures. The other products of the reaction are solid copper and water vapor. If a sample containing 18.1 grams of ammonia and also 90.4 grams of copper oxide are reacted in this case. Now we want to determine one, the limiting reagent. So how do we get to determine the limiting reagent? Well, the first thing that we need to have is a balanced chemical reaction. And this chemical reaction which is here is already balanced, so we'll just get to use it. Now to be able to determine the limiting reagent, one thing that we are going to do is we are going to first determine the moles of ammonia and the moles of copper oxide. So starting with the number of moles of ammonia, and we know the number of moles is given by the mass divided by the molar mass. So in this case, the mass of ammonia that has been given is 18.1. Molar mass for ammonia is 17.03. Therefore, that is going to give us a 1.06 more as the number of moles of ammonia. And then we determine the number of moles of copper oxide. Same formula, that is mass divided by the molar mass. So in this case, the mass of ammonia, I mean copper oxide that we have, that is 90.4. The molar mass of copper oxide 79.55. This is going to give us 1.14 moles of copper oxide. Now we want to determine which one of these two is the limiting reagent. So one thing that we can do is, when we have got these moles of ammonia, how many moles of copper oxide do we expect to react with them? And when we've got these moles of copper oxide, how many moles of ammonia do we expect to react with them? So we can take any of them and then determine the moles of the other that is expected to react with that one. So in this case, let me take ammonia and determine the moles of copper oxide that are supposed to react with ammonia. So now the first thing is we're going to determine the mole ratio that we have here. So for each 2 moles of ammonia, we expect to react with 3 moles of copper oxide. Now I want to determine the moles of copper oxide that is supposed to be reacted with ammonia. So I'm going to put the moles of copper oxide on top. So we're saying 3 moles of copper oxide per 2 moles of what? Ammonia. Okay, like that. So this is what we have. For every 3 moles of copper oxide, we are supposed to react 2 moles of ammonia. Now we are going to multiply. How many moles of ammonia do we have? So we see we have got 1.06 moles of ammonia. And well, this is just dimension analysis, because we can see we have got moles of ammonia down, so we're going to have moles of ammonia on top. And what is going to happen is the more ammonia is going to cancel with the more ammonia here. The answer is just going to remain as the moles of copper oxide. So if we perform the operation, we're going to get 1.59 moles of copper oxide. So these are the moles of copper oxide that is supposed to react with these moles of ammonia. Now let's compare. If these are the moles of copper oxide that are supposed to react with these moles of ammonia, how much moles of copper oxide are present? So we can see that the moles of copper oxide which are present, we've got 1.14, but the ones we expect to react is 1.59. So the ones we expect to react with ammonia is more than what is available. That means the copper oxide is the limiting. So we need to give that statement as we finish. Since the moles of ammonia which are available are less than the moles, the moles of copper oxide which are available are less than the moles of copper oxide which are expected to react with ammonia. Therefore, copper oxide is a limiting reagent. So we could have also determined the mass. I can just get these moles and then multiply by the molar mass for copper oxide. And then we're going to see the mass of copper oxide that we are going to have. In comparison to this mass which is here, we can also deduce that. But it is all the same. We're also going to find that the mass is going to be higher than the mass which is given, the 90.4. That will still tell us that copper oxide is the limiting reagent. Now that we've determined the limiting reagent, and we know that the limiting reagent is what determines the amount of product. Good. Another way that we can do it to determine the limiting reagent is we can get any product. So we want to determine, let me in this case talk about nitrogen. So when we use this mass of ammonia, how much nitrogen are we going to produce? And when we use this mass of copper oxide, how much amount of nitrogen are we going to produce? Now in this case I'm not going to use mass, but I'm going to use the moles. So we want to determine the number of moles of ammonia, nitrogen, that we are going to get if we use any of these two. Now because I want to get the moles of nitrogen, then I'm going to have the moles of nitrogen on top, but we are going to compare the mole ratio. So we are saying that for every 1 mole of nitrogen to be produced, let's start with ammonia, we are going to use 2 moles of ammonia. So I've got a moles of ammonia down, then we are going to multiply by moles of ammonia also which are available. So 1.06 moles of ammonia. So here we're going to see that the more ammonia and the more ammonia is going to cancel. So what we are just going to have is 1.06 divided by 2, and that is going to give us 0.53 moles of nitrogen gas. So this is when we use the moles of ammonia that are available. What if we use the moles of copper which are available? So we're also going to say for every 1 mole from the balanced chemical reaction, we are saying that for every 1 mole of nitrogen, how much copper oxide are we supposed to use? So we are seeing 3 moles of copper oxide. And then we're going to multiply now with the number of moles of copper oxide which are available, and that is 1.14 moles of copper oxide. So more of copper oxide and more copper oxide is going to cancel. So 1.14 would be divided by the 3, and that is going to give us 0.38 moles of nitrogen. Now we can see that when we use copper oxide, we are getting 0.38 moles. When we use ammonia, we are getting 0.53 moles. So when we are using this method to determine the limiting reagent, we are going to look at the smallest moles which have been produced. So in this case, we can see that copper oxide has produced the smallest number of moles of product. That means copper oxide is the limiting reagent. So up to you to determine which method you are going to use to be able to determine the limiting reagent. Now the next question is how many grams of nitrogen will be produced? We've already determined the number of moles of nitrogen that are going to be produced. And whenever you're determining the amount of product produced, you always use the limiting reagent. So we use the limiting reagent to determine first the number of moles of nitrogen that is going to be produced. We said for every 1 mole, this is for part B, for every 1 mole of nitrogen, using the limiting reagent, we have got 3 moles of copper oxide. we are going to multiply by the number of moles of copper oxide which are available, that is 1.14 moles of copper oxide. The copper oxide moles are going to cancel, just going to remain with the moles of nitrogen, and that is going to give us, we saw that it gave us 0.38. Now that we've determined the moles of nitrogen, let's determine the mass, because the question is saying how many grams. So we know that mass is given by number of moles multiplied by the molar mass. So in this case, the number of moles is 0.38 times molar mass. Well, we've got nitrogen molecule. Determining the molar mass, the value that is on the periodic table, we're going to multiply it by 2 because we're talking of nitrogen molecule, not nitrogen atom. And that is going to give us 28.02. So the mass of nitrogen that we're going to determine is 10.6 grams. So this is the amount of nitrogen that is going to be produced in this chemical reaction. Now for the last part, what mass of excess reagent remained in excess? So if the chemical reaction has happened, we've seen that ammonia is the excess reagent. So what mass of this excess reagent is going to remain? And how do we determine that? Well, the first thing is we need to determine, firstly, the amount of ammonia that is going to react. The amount of ammonia that is going to react. So let's determine that. And here we know that for every 2 moles of ammonia, we have got 3 moles of copper oxide reacting. I'm putting the copper oxide down because I want it to cancel. What I want to determine are the moles of ammonia to be formed. So we're now going to multiply. How many moles of copper oxide do we have present as the limiting reagent? So the moles of copper oxide which we have is 1.14. So let's get to calculate this. We have got 2 over 3 multiplied by 1.14, and that is going to give us 0.76. These are moles of ammonia. Now we've determined the moles of ammonia. These are the moles of ammonia that are going to which are going to react with 1.14 moles of copper oxide. But these are not the moles of ammonia which are available. We determined the moles of ammonia which are available. Now I could have subtracted, but let me go and find the mass of ammonia because I want to determine the mass of excess reagent. So what will be the mass of ammonia that is going to react? And we know that mass is given by the number of moles multiplied by the molar mass. The number of moles 0.76, the molar mass of ammonia, that is 17.03. And let's see what we get. So this is going to give us 12.9428 grams of ammonia. So we are seeing that these are the only this is the only mass of ammonia that is going to react. But consider the mass of ammonia that has been given is 18.1 grams. So how much mass is in excess? So the one which is in excess is the mass that is available, 18.1, minus the mass that is going to react, which is 12.9428. That is going to give us now the mass that is going to remain. So this is going to give us 5.1572, and which we can give as just 5.2 grams of ammonia. This is the mass of ammonia that is going to remain in excess. Thank you so much for watching. Hope this was helpful, and remember to subscribe and stay blessed.